What is a rational expression? Not irrational with an I, but just rational expression. What is that referring to? Well, if you look at the word rational, you'll notice that it contains the word ratio, right? And that's because a rational expression is referring to a fraction, right? Where you have maybe one polynomial divided by another, or some term with an x divided by another term with an x, something like that. An example would be something like 12x squared divided by 6x. This is technically a rational expression, right? It's rational because you have a fraction, right? It's a ratio. If I was asked to simplify this, you would just look for the terms on the top and bottom that cancel, right? Or reduce. For example, 12 over 6 reduces to 2. X squared over x reduces to x, right? You subtract the exponents. So that's a straightforward one. What if we have something a little bit more complicated? What if I have x plus 2 divided by x plus 2 times x minus 1? Well, you notice that the x plus 2 and x plus 2 on the bottom will cancel, and so you'd be left with 1 over x minus 1. However, we would have to state some restrictions here, right? Because as we know, you're not allowed to divide by 0, so this can't be true for every value of x, right? For example, it's not true when x is equal to 1, because if you plug in 1 here, 1 minus 1 is 0, and you can't divide by 0. So you have this restriction. You also have the restriction for this bracket that we canceled out earlier, right? Because if that was equal to negative 2, right? If that x was equal to negative 2, then you'd have 0, and you can't divide by 0. So you have two restrictions here that you would have to list. Okay, so keep that in mind for these questions. Let's do another one. Let's say you have x minus 1 divided by x squared minus 1. Well, here it doesn't look like anything cancels right away, right? Like you can't cancel this 1 and 1 because we're subtracting, right? You have x squared minus 1. These are two individual terms, right? Same with the top. If you want to cancel something, you have to cancel it from all the terms. So you can only cancel things out if they're being multiplied, right? Typically. So what do we do? Well, what you're going to want to do is you're going to want to try to factor. And that's a key theme throughout these questions, is you're going to try to factor everything that you have. So the top is just x minus 1. The bottom is a difference of squares, right? So the bottom is x minus 1, x plus 1. From here you can cancel your x minus 1s, right? And then you're going to be left with 1 over x plus 1. And then you state your restrictions, right? X cannot equal 1 or negative 1. You have both of those restrictions. Okay? And that's because of these brackets here. If x is equal to negative 1 or 1, that would become 0, and that is not okay. Let's do another one. Number 4. Let's say you have x squared plus 3x plus 2 divided by x squared minus 4. So again, we're going to factor the top and bottom. Top looks like a simple trinomial. So we can say, hey, what multiplies to 2 and adds to 3? I think you'd have 2 and 1, right? X plus 2, x plus 1. Bottom's a difference of squares. X minus 2, x plus 2. If you need to review factoring, go back and watch those videos that we have on all the different types of factoring, right? We can't forget that stuff because we're going to be using it all the time. What cancels out here? Well, I think the x plus 2 and x plus 2 cancel, and you're left with x plus 1 over x minus 2, and your restrictions will be x cannot equal 2 or negative 2, right? Because if this x is 2, it's 0. If this x was negative 2, that would also be 0. So we can't have x equal 2 or negative 2. But for every other x value that you plug in here, this is going to equal this, right? That's the idea. We want to simplify this into this so that if you plug in a value for x here, or if you plug it in here, you get the same answer. So this is true as long as x doesn't equal one of these ones, right? If x is one of those, then this isn't going to work because it's going to be undefined. Now, let's do another one. Number 5. Say you have x plus 1 over x squared minus 4 plus x minus 3 divided by x plus 2. What do we do here? Well, you're going to need a common denominator, right? And what I'll do first actually is I'm going to factor the bottom on this left side just to show what it really looks like, right? Just to show all the factors. So that's going to be x minus 2, x plus 2. And the reason that's beneficial is because now I can see that both sides share a factor already in their denominator, right? So when I need to make a common denominator, I just have to multiply this by x minus 2 over x minus 2, because now the denominators are the same. And now, when I add these things together, you have x minus 2, x plus 2 on the bottom. And on the top, you have x plus 1 plus x minus 3 times x minus 2. You can expand this thing on the top. You can FOIL it and then collect like terms, and then try to factor it and see what cancels, right? That's the idea. So let's do that on the top. You'll have x plus 1 plus x times x is x squared. X times negative 2 is negative 2x. So you'll have negative 2x. Negative 3 times x is negative 3x. Negative 3 times negative 2 is plus 6. And that's all over x minus 2, x plus 2 still. You want to simplify the top, right? Collect like terms. So you'd have x squared minus 3x minus 2x plus x will be minus 4x, and then 6 plus 1 is 7. And that's all over x minus 2, x plus 2. Now the next step would be try to factor the top, right? And if you can factor it, then see if any of the factors cancel out. Unfortunately, if you look at the numbers that multiply to 7 and add to negative 4, it doesn't really look like any number combination is going to work, right? The only numbers that multiply to 7 are 7 and 1, or negative 7 and negative 1. And there's no way you can use those numbers to add to negative 4. So unfortunately, we're done here. We can't factor and cancel anything out. Sometimes you can, and it works out very nicely. For this one, we can't. So we're done here. All you do is state your restrictions. X cannot equal negative 2 or 2 because of these brackets. Okay, let's move on to the next one. Number 6. Okay, so number 6 says we have x plus 5 divided by x minus 2 plus negative 14x divided by x squared minus 4. So you want to do the same thing here, right? The second one, you can obviously factor that denominator. So you'll have x minus 2, x plus 2. And on the top, you just have minus 14x. And that reveals that you do have a part of your denominator, a factor that's similar to this one. So we're actually pretty close to getting a common denominator. You just have to multiply this thing by x plus 2 over x plus 2. Because now the denominators will be the same. So now your denominator is simply x minus 2 times x plus 2. And on the top you have these two things multiplied, so x plus 2 times x plus 5 plus, or I should say really, minus 14x. Just like that. Now we can expand this, right? We can FOIL it. X times x is x squared. X times 5 is 5x. 2 times x is 2x, so add those together, you'll get 7x. And then 2 times 5 is 10, minus 14x, all over x minus 2, x plus 2. Finish collecting like terms here, you'll get x squared minus 7x plus 10 divided by x minus 2, x plus 2. Now see if we can factor the top, right? Your numerator, what multiplies to 10, adds to negative 7. I think negative 5 and negative 2, right? So you could have x minus 5, x minus 2, all over x minus 2, x plus 2. The x minus 2's will cancel, and you're left with x minus 5 over x plus 2 as your final answer. You just have to state your restrictions. X cannot be negative 2 or positive 2. Let's look at another one. Number 7. Let's say you have 5x minus 10 divided by x squared minus 4. And now we're multiplying by x squared plus 3x plus 2 divided by 15. So in this question, we're just multiplying, right? We're not adding, so we don't have to worry about a common denominator. All you have to do is start factoring, right? If you look at the 5x minus 10, you can factor out a 5. You'll be left with x minus 2. Underneath that, you have a difference of squares. So x minus 2, x plus 2. We then multiply that by, so you have 15 on the bottom, that stays the same. And on top, you'll have a simple trinomial. What multiplies to 2 and adds to 3? I think 2 and 1. So x plus 2, x plus 1. And what's nice about multiplying is you can cancel things in different fractions, right? So like this x plus 2 will cancel this x plus 2. This x minus 2 cancels this x minus 2. And all you're left with is 5x plus 1 over 15, which of course you can reduce the 5 over 15, right? And you'll be left with x plus 1 over 3. And that's your final answer. All you have to do now is write your restrictions. X cannot be 2 or negative 2 because those were the factors in the bottom. If x is equal to either of those numbers, the bottom becomes 0 and it's undefined. Okay, let's move on to another one. Number 8. We have x squared minus 6x plus 8 divided by x squared minus 16 times x squared minus 9 divided by x squared minus 5x plus 6. Okay, so we just factor everything, same as the last question. Simple trinomial up here, what multiplies to 8 adds to negative 6, I think negative 4 and negative 2. So x minus 4, x minus 2. Just below that, difference of squares, we have x minus 4, x plus 4. Over here, difference of squares on top, x minus 3, x plus 3. And on the bottom, another simple trinomial, what multiplies to 6 and adds to negative 5, x minus 2, x minus 3. Now we have some fun, we start canceling things out. X minus 2, x minus 2, x minus 3, x minus 3, x minus 4, x minus 4. And all you're left with is x plus 3 on top, right here, divided by this x plus 4 right here. That's your final answer. You go ahead and you state your restrictions. X cannot equal negative 4, positive 4, positive 2, positive 3. Those will be your restrictions. Okay, one more question. Let's say, here, number 9. Let's say we have x squared minus 13x plus 30 divided by x squared minus 100, and then divided by, we have a little division symbol here, x squared plus 1x minus 12 divided by x squared plus 14x plus 40. Usually we don't write the 1x, right? We just put x, but just put a 1 there, right? Why not? So now, what do we do? Well, because it's division, that's kind of a pain, right? We don't really like that there's a little division sign there. We're used to that being multiplication. So the first thing I would say is change it to multiplication. And you can do this. You can change from division to multiplication. All you have to do is flip the second fraction. Okay, so that's what we're going to do. We're just going to flip the second fraction when we go from here to here. We're going to flip. So you can actually write that step first. You can flip this and then write it all out again. But what I'm going to do is I'm going to start factoring. Right? I don't want to write that extra step. So let's start factoring. So x squared minus 13x plus 30, simple trinomial, x minus 3, x minus 10. Because negative 10 times negative 3 is 30. Add them together, you get negative 13. Bottom's a difference of squares. X minus 10, x plus 10. Just like that. Over here, again, we're going to flip. So when I factor this top, I'm going to put that on the bottom. Okay, because we're flipping it upside down. So simple trinomial, what multiplies to negative 12 adds to 1. I think x plus 4, x minus 3. Right? 4 times negative 3 is negative 12. 4 minus 3 is 1. And then here, when we factor this, I'm going to put that on the top. So another simple trinomial, I think you get x plus 4 and x plus 10. Now we just start canceling things out, right? X minus 3, x minus 3, x plus 4, x plus 4, x plus 10, x plus 10, x minus 10, x minus 10. And the answer you get is just 1, right? If everything cancels, if everything divides, you're just left with 1. Now you do have some restrictions, right? X cannot equal 10, negative 4, or 3. So this entire expression up here is equal to the number 1 for any number of x that you plug in, right? You can pick any number for x, plug it in, and you're going to calculate it to be 1, with the exception of these numbers. If you plug in one of these numbers, your answer is going to be undefined. But any other x value you can plug in and you'll calculate it to be 1.